In this example, we are given the proportion of students taking Japanese and/or French. And we are asked to find P of Japanese or French, or P of J union F. Well, there's no direct info on this. So let's use the addition rule by replacing event A with J and event B with F. That gives us this. P of J is equal to 0.3. P of F is equal to 0.25. And P of J intersect F is equal to 0.08. And that evaluates to 0.47. If we want to use a Venn diagram to help us visualize, then we have to first note that it is possible for the students to take Japanese and French at the same time. So they are not mutually exclusive. Hence, we draw two overlapping circles, with the middle intersection taking on the probability of 8%. So what's the probability of students who take Japanese only but not French? Well, the 30% given here refers to the whole circle of J. Hence, this region takes on the value of 30 minus 8%. Now, what is the probability of students who take French only but not Japanese? Well, the 25% given here refers to the whole circle of F. Hence, this region takes on the value of 25 minus 8%. If we add these three regions in the circles together, they should add up to exactly 47%, as indicated by our calculation earlier. In this example, we are given that 100 out of the 120 adults take at least one type of loan. 65, 45, and 42 take up home, car, and renovation loan respectively. 20 take up home and car loan. 25 take up home and renovation loan. 15 take up car and renovation loan. And 8 take up all three loans. We are asked to draw the Venn diagram. To do that, we first note that it is possible for any one adult to take up more than one type of loan. So the three loan types are not mutually exclusive. Hence, we draw three overlapping circles. To fill the relevant number for each region, we always begin with the middle intersection where all three loans coincide. We are told that 8 took up all three loans, so the number in this region is 8. What about this region? How many people belong here? We are given that 15 take car and renovation loan, but that's the whole area here. Hence, we have to take 15 minus 8 to get 7 for this region. What about this region? We are given that 25 take home and renovation loan, but that's this whole area here. Hence, we have to take 25 minus 8 to get 17 for this region. What about this region? We are given that 20 take home and car loan, but that's this whole area here. Hence, we have to take 20 minus 8 to get 12 for this region. Next, what about this region? We are given that 42 take renovation loan, but that's this whole circle here. Hence, we have to take 42 minus all the intersecting regions of 17, 8, and 7 to get 10 for this region. What about this region? We are given that 45 take car loan, but that's this whole circle here. Hence, we have to take 45 minus all the intersecting regions of 12, 8, and 7 to get 18 for this region. What about this region? We are given that 65 take home loan, but that's this whole circle here. Hence, we have to take 65 minus all the intersecting region of 12, 8, and 17 to get 28 for this region. What about this region outside the three circles? Well, we are told that 100 out of the 120 adults take up some loans. Hence, the remaining 20 did not take up any loan. Next, part B. To get the probability of adults that take exactly one loan, well, that's these three regions without any intersecting area. Add them up to get the answer as 56 over 120. To get the probability of adults that take exactly two loans, well, that's these three regions where two loans intersect, but not all three. Add them up to get the answer as 36 over 120. To get the probability of adults that do not take any loans, well, that's just this region outside the three circles, which is 20 over 120, or the universal set minus everything in the three circles.